Welcome to qnawire.
All right, so to do this problem, I'm going to first look at the Lewis structures because they're a little bit more simple. So we have Cn in all cases. And the only thing that's going to differ here are the number of electrons that we have. So in Cn plus, we get 4 from carbon, 5 from nitrogen, for a total of 9, and then we lose 1 because we have a positive charge. So it has 8 electrons. Here are just going to be 9, like I said earlier. And then for Cn minus, we have 10 because there's an extra one from that minus charge. So for this first one, we know that we're definitely going to have a bond here. And if we have 8 electrons, then we can only fill up essentially 1 octet. So we're going to need a triple bond here. And then I'm going to fill carbon's octet. And that's going to leave nitrogen with essentially a non-filled octet. So that's not going to be very stable from Lewis' perspective because it's violating the octet rule. We can't form a quadruple bond, so there's nothing we can do about that. For this bond, we have 9 electrons. So again, we're going to start with this triple bond. We're going to fill up carbon's octet, and then nitrogen gets 1. We could have also drawn it with nitrogen having 2 and carbon only having 1. The advantage here is that carbon's now neutral. This is a lone electron pair. It's also not going to be very stable. And then for Cn minus, we draw these 6 in the middle, and we have 4 left over, so we can fulfill each octet. So let's keep in mind that these are minus and these are our plus. For the molecular orbital diagram, all the diagrams are going to look the same, so I'm just going to draw one diagram and then fill in a different number of electrons. So we start with our s orbitals here, our sigma, when they become molecular orbitals. And we'll go into the pi electrons, which have like this. Since carbon and nitrogen are in the first half, these pi electrons are lower in energy than the sigma. And they're followed up by their antibonding pairs. So if we're going to fill this up with 8 electrons, I'm going to put the bonding ones in green and the antibonding ones in red. So this is 4. And then we get to fill 5, 6, 7, 8. And now that's what it would look like for 8 electrons. For 9 electrons, we put 1 in here. And for 10 electrons, we put another 1 in here. So since these last 2 electrons went into bonding orbitals, that's going to make it more stable. So for this one, it agrees that for the molecular orbital diagram, it agrees that this Cn minus is going to be the most stable. And for Lewis, we also have this as the most stable, because it's the only one that we can fulfill 2 octets in without any sort of lone electron pairs or missing octets. So yeah, so this is the most stable for both of them, and they do agree in this case.